In this video, I'm going to demonstrate how to recalibrate the Niro analyzer. To get started, you have to do this procedure using the analyzer controller, which is the program that runs on the analyzer controller host, typically which runs in a window that you don't see. So you have to get the analyzer controller running in a window that you can interact with. One way to do that is to click the Windows Start button, go to All Programs, Guided Wave, OmniView, Restart Niro Controller. You have to wait for it to come up, and it's going to run in what we call automatic mode, which means it's going to do some startup checks and then it's going to start reading its schedule. So what we want to do is, after it finishes its startup tests, we want to put it in the manual mode, after which time we'll be able to enter commands at the command line. So we're going to have to wait for it to do its startup checks, which are a couple of validation scans. Okay, once it's in automatic mode, we can type man or manual to put it into interactive mode. Don't be alarmed if the analyzer is trying to do scans at this time. You can type and it will see your typing even though it's doing a scan. So now I'm in manual mode. What we want to do, what we're going to do is we're going to start by calibrating the reference channel, and if that works, then we will calibrate all channels. So to calibrate a channel, we're going to select the channel. We're going to type channel reference 1, and then we're going to type calibrate. Typically, you should not need to do this procedure at all unless you've had trouble with the grating slipping on the motor shaft, or you've had to reset the grating on the shaft for whatever reason. So it performed the calibration scan, and it did the math necessary to come up with the calibration coefficients. A couple of things to look for. First of all, did it correctly finish? And we know that it did by what it says here. Another thing to look for is the standard error of the fit. We show that in a couple different places here. Once here and another time down here. Oops. We want this value to be under 0.1. If it gets above 0.1, then we're not getting a very good calibration. So check to make sure that that value is under 0.1. Now, it's asking me if I want to use this calibration. I'm going to say no, because the next step is to calibrate all of the channels, and we can do that with one command, and it will scan every channel, calibrate every channel, and save the coefficients for us. So the way to do that is to type channel all calibrate. It's warning you that you need to have jumpers attached on all channels. If you don't, then the calibrations will fail on those channels, but I'm going to assume here that you have jumpers attached on every channel In other words, both reference, or if you have a 6 channel, it's just one reference and the other 6 channels. If you have a 12 channel, it's going to be 2 reference fibers and the 12 channels. You initiate it by responding with a Y for yes. And now it's going to perform calibrations on all channels. Now this will take a few minutes. And as they go by, look for the standard error of the fit. So far they've been pretty good calibrations. Just about halfway down now. I have a 12 channel here in my office. There are a couple of things we need to do after this is finished, so hang in there. Okay, we've successfully calibrated all 12 channels and both reference channels on this analyzer. The next thing to do is to save these coefficients onto the analyzer flash memory. We do that by typing coefficients save. And go ahead and confirm with a Y. This writes the calibration coefficients onto the flash EEPROM on the multiplexer, so that if the coefficients ever get lost out of memory, or if this spectrometer and mux unit goes to another unit, the coefficients go with them. One more thing to do would be to validate the analyzer at this point. So we're going to say channel ref1 validate. Now, if you've recalibrated after having to move the grating, it's possible that the validation will fail because there's going to be a significant shift in the x-axis. So if it had failed, what you need to do is produce a new validation scan. The way to do that is to type val scan save. This takes a scan of the validation filter and then saves it to a special file, and it also saves it in the database for future use. Okay, that's it. We have recalibrated all channels on the analyzer. We've validated the coefficients. We've produced a new validation scan for future use, and we are finished. Thank you.